To use synthetic division to find the roots, we first need to find out what a possible real rational root is of this polynomial. So in order to do that, you can do a few things. You can type it into your calculator and try to find a zero that way, or we can look at the first term, the leading coefficient, which in this case is just a 1, and the last term, which is a constant, which in this case is a 30. Now that's going to give us all of the possible rational roots. So the possible rational roots would be for 30 over this 1, positive or negative 30, and a positive or negative 1 of this number and put them over the factors of this number. Now this makes it easy because it's a 1, so we can list all of these possible rational roots. Now I'm going to start with the smallest just to make it easier, and you take your calculator and you plug in, let's say, positive 2 first. So you would do positive 2 to the 4th plus positive 2 to the 3rd minus 11 times 2 squared minus 5 times 2 plus 30. When you do this, you get 0, which means the coordinates of that point are 2, 0, which means that this is a root. This is a 0 of our polynomial. So that means that we can say that x minus 2 must be a factor of that polynomial because 2 is the root. So that means if I were to set this equal to 0, I'd add 2 to the other side and I'd get my root. Now when I use synthetic division, I'm going to use that 2 to use synthetic division, as well as all of the coefficients of this original polynomial. So using synthetic division, I bring down the first number, then I do 2 times 1, which is 2, 1 plus 2, which is 3, 2 times 3, which is 6, negative 11 plus 6, which is negative 5, 2 times negative 5, which is negative 10, negative 5 plus negative 10, which is negative 15, 2 times negative 15, which is negative 30, and that's going to give me a remainder of 0. Now these terms, this is the constant, this is the x to the first term, this is the x squared term, and this is the x to the third term, so just a 1. So now we have that x minus 2 is factored out and leaves us with that binomial and the polynomial, which is what's remaining. Now I'm going to use the rational roots theorem again to try to break this down further because it's still not a quadratic yet and I can't factor it. So I'm going to use the rational roots theorem to give all of the possible factors of the negative 15 and the positive 1. So that could be positive or negative 15 over 1, positive or negative 1. I could also have a positive or negative 3 and a positive or negative 5. Now again, start with some of the smaller numbers. It will just make it easier. So let's say we're looking at the negative 3. Negative 3 to the third plus 3 times negative 3 squared minus 5 times negative 3 minus 15. And please make sure you have these in parentheses when you type them into your calculator, otherwise you'll get a different answer, equals 0, which means that negative 3, 0 is a point on that graph, and more specifically it's a 0 or a root, which means that negative 3 is a root, so x plus 3 must be a factor. So now we're going to use synthetic division using that negative 3 and what was left, these coefficients, once we factored out the x minus 2. So we're using the negative 3. I'm going to bring down the 1. Negative 3 times 1 is negative 3. 3 plus negative 3 is 0. Negative 3 times 0 is 0. Negative 5 plus 0 is negative 5. Negative 3 times negative 5 is a positive 15, and when I add those, I get 0. So my remainder is 0. My constant is negative 5. This means my linear term, my x to the first term, is 0x, so I don't need to write that because that's just 0. But then my x squared term has a 1 in front. So now I have my x minus 2, my x plus 3, and what's left is my x squared minus 5. I can solve this now for the roots, if that's what it's asking me for. If it's just asking me to factor, this would be my final. But if it's asking me for the roots, I can now solve this. Because this part is going to give me x minus 2 equals 0, so x equals positive 2. X plus 3 equals 0, so x equals negative 3. And x squared minus 5, so I add the 5, I get x squared equals 5. Take the square root, positive and negative, because I'm drawing the square root symbol. So x equals the positive or negative square root of 5, which makes sense because if I have the positive square root of 5, I have to have the negative square root of 5. We started off with a quartic, which means we need 4 roots in the end. So we have negative 3, we have 2, and positive or negative radical 5 would be our final answer to this problem.